All right, it's Mr. N here, and we are going to do the Chapter 7 review in class because it's game day.
Yeah.
All right, here we go. Find the measure of each in the parallelogram shown. So for this first one, DA, we're looking at right here. And since this is a parallelogram, we know that opposite sides will be congruent. So these two will be congruent. So we could say that DA is 11.7 as well. Okay, for AB, again, same reason. Opposite sides are congruent. That will be 8.5. All right, so the measure now of angle BEC. BEC, this angle right in here. Well, we know that AED will be vertical to it. So if I could find what this is right there, it'll be the same. And I can because I'm given two other angles. So since this is 30 and this is 37, so here we end up with 180 for the triangle. Minus the 30 gives me the 160, and then the 160 minus the 37 will give me, this will be 150, sorry. 150 minus the 37 is going to give me 113. So this angle in here is 113. So that angle will be 113 as well. So this is 113 degrees. Okay, so now for part D, we have to find the measure of angle ABC. So ABC, this angle in here. Well, if I know that I have a parallelogram, these are alternate interior angles. So that means this angle in here will be 37 degrees, the same as this one. And I need this angle right in there. Okay, so our task is to find this angle right here. So I can add these up. This angle will be the same as that right there because these are parallel lines cut by a transversal. I can do it. There are a couple different ways to do this, but this is one of them. If I can find these two. So that means I got to find what this one is. Well, if this whole thing is 65, this plus this equals 180. So here's what we're going to say. We're going to call this one our x right there. So I know 180 is going to be the 37 plus the x plus this angle in here, 65 degrees. So these all add up to be 180. So I can go ahead and solve for that x, and that's going to be 180 minus the 65 minus the 37, which will give me 78 degrees. So this ends up being 78 degrees in here, which means this is 78 degrees there. So 78 plus the 37 will give me a total of 115. So this angle in here is 115 degrees. Now, we can double check to see if that makes sense because this 115 plus whatever this one is, and these two will be the same since it's a parallelogram. Opposite angles will be congruent on that one. So we could say the 115 plus 65, does that come out to be 180? And it does. Okay, take a look at the next one. The measure of angle ACD. ACD, right there. Okay, well, we found this to be 75 or 78 right in here. So if this is 78, I can get this one, and then that'll leave me with that. Or so there's multiple ways to get this answer. But since we know that the opposite angles of a parallelogram will be congruent, I could say, since this whole thing is 65, that whole thing has to be 65 also. If this is 30, then I can find what this piece is. It'll be the same as the other one. So we could say 65, this whole thing, minus the 30 will give me that piece that I need, which ends up being 35. Let's go ahead and do this last one, and now we need to find the measure of DBA. D to B to A, but we had already found that in one of the previous problems, and what was that? 78. So this is 78 degrees. Okay, moving on to number 2. In number 2 it says use the figure to answer each, and we are going to make the assumption that this is a parallelogram. So for the first one, we are given that the measure of ADC is 89. ADC, this whole thing is 89. And then we have to find the measure of angle ABC. Well, we know that this is a parallelogram, so opposite angles will be congruent, so that's 89 degrees as well. Part B, if BD is 10, so this is a whole different question now. If BD is 10, what will B to E be? Well, the diagonals on a rectangle or on any parallelogram bisect each other. So if BD is 10, that piece will be 5. Okay, moving on to the next one. If AB equals 6x minus 1, so AB is 6x minus 1, we'll write it up here, 6x minus 1. And DC is 2x plus 3. We have to find x. Well, we know that the opposite sides on a parallelogram are congruent, so I could say 6x minus 1 equals a 2x plus 3. So this is 4x, subtract 2x from each side, add 1 to each side, equals 4. So x is 1. All right, next one. Okay, for part D, if AE is 10, so if A to E is 10, again, this is a whole different problem. If A to E is 10 and A to C is 2x plus 1, find x. Well, we know, again, the diagonals on a parallelogram bisect each other, so we can say that this AC, 2x minus 1, AE will be twice that. A to E will be half that, so 2x plus 1 will be 20. So I took this and I doubled it. It'll be 20 all the way across. So 2x equals 19, so x equals 19 over 2. Okay, if ABCD is a rectangle and DE is 8, find AE. Well, this time, if we have a rectangle, we know that on a rectangle, the diagonals not only bisect each other, but will be congruent. So if D to E, this was 8, and we want to find A to E from here to here. This is A, there's E. It's going to be the same value, 8. Okay, part F. If ABCD is a rhombus, so now we have a rhombus. And on a rhombus, the opposite sides will be congruent. Then we need to find the measure of angle AED. So AED is this diagonal, this angle right here on this diagonal, and we know on a rhombus these will be 90 degrees because the diagonals will be perpendicular to each other. All right, moving on to number 3. We have to find x in each of these. Okay, in this first one, we know that the sum of all these angles in a polygon add up to be n minus 2 times 180. That's the sum of all the interior angles. So n minus 2 times 180 is the sum. And in this case, we've got 1, 2, 3, 4, 5 sides. So 180, 5 minus 2 equals my sum of all those interior angles. So that's going to be 3 times the 180, which will give me 540 as my sum. So that means every single one of these added up comes out to be 540. So let's add them up. 80 plus the x plus 40 plus the 125 plus the x plus 50 plus the x plus 5. All of this equals 540. So we can solve this. I've got 1, 2, 3 x's. So 3x plus 80 plus this 40 is 120 plus the 125 plus the 50 and the 5 here. All of this comes out to be 300. So 3x plus 300 equals the 540. So 3x equals 240. So x is going to be 80. For the next problem, it's the same thing. 1, 2, 3, 4, 5. Oh, I should have given you one without 5 sides. Should have given you like one with 6 sides. So sorry about that. Didn't realize that those were both the same. But we already know what the sum will be now. The sum will be 540 since we already did this. So x plus 20 plus the 70 plus the 135 plus the x minus 15 plus the x minus 45. All of this equals 540 again. So we're going to go through and solve for x. So I've got 1, 2, 3 x's again. And then here, let's add up all these values. We got 20 plus 70.
90.
20 plus 70 plus 135 minus 15 minus the 45. All of this comes out to be 165. So plus 165 equals the 540. So 540 minus the 165, and then divide that by 3. X ends up being 125. All right, moving on to number 4. So on number 4, we've got if EH is equal to FG, that means I have an isosceles trapezoid, and the measure of angle E is 55 degrees, then the measure of angle G will be what? And the measure of angle GKJ, this one in here, will be what? Well, if this is 55 degrees, since this is 55, these, let's do it this manner. These will be supplementary, right? Because we got parallel lines cut by a transversal. And we know that these will be congruent. So we can also say these will be supplementary on the opposite sides. So 180 minus the 55 yields 125. So this angle is 125 in here, which means that's 125 as well. So this is 125. Now, since this is 125, that'll be 55 because these are supplementary in there as well. Okay, number 5. If EF is 23 and JK is 3x and GH is 2x plus 1, then x equals what? Well, we know that this is a median. It's a mid-segment because they tell us these are congruent on this end and these are congruent on that end. So that's a mid-segment, which is a median. So that means if I take the 2x plus 1 plus the 23 and take half of that, that should equal 3x. So I'm going to multiply everything by 2, so I end up with 2x plus 1 plus 23 equals 6x. Now I'm going to go ahead and solve for x, so 2x plus 24 is 6x. 24 equals 4x. X will be 6. Okay, moving on to the next page. We're given this kite, and we have the measure of angle XUV. XUV, this one right in here is 74, and the measure of angle WVX, that angle in there is 58, and this one we said is 74. We need to find the measure of angle VWX. So VWX, we got to find that one in there. So part of the properties of a kite that we know is that V and X will be congruent. But we also know that the diagonals, it bisects this angle in here. We know that that's going to be a right angle. So this is something I can solve for. So I know 90 minus the 58 will give me what this angle right in here equals. So 90 minus the 58 will give you 32. So that's 32. So that means this whole thing is double that. So the measure of angle VWX will be 64 degrees. Okay, moving on to number 7. What is the best name for a quadrilateral with these vertices? So let's go ahead and plot this one up here. And we'll do the best we can with this plot. So let's put these values in. We've got -4, -1. We've got -4, 6. We've got 2, 6. And we've got 2, -4. So -4, -1, -4, 6, 2, 6, and then we've got 2, -4. So let's draw this. I've got that, I've got that, I've got this, but then I've got that. What is this? This is going to be a trapezoid. That's the best name I can come up with this. Okay. An interior angle of a regular convex polygon measures 140 degrees. How many sides does it have? So for this one, we're going to use the formula n minus 2 times the 180. But then I need to divide it by n because each angle will be 140. So this time I'm dividing it by n because it's regular and I know what each angle is. So the trick is to solve this. So what we're going to do is we're going to cross multiply first. I'm going to multiply each side by n. So I end up with these reducing out. So 180 times n minus 2 equals 140n. I'm going to distribute. So 180n minus 360 equals 140n. Now I'm going to add 360 to each side and then subtract 140. So I end up with 40n equals 360. Now divide each side by 40. So n will be 9. So 9 sides. Okay, if an exterior angle, this is an exterior this time, of a polygon measures 50 degrees. What is the measure of the interior angle adjacent to it? So what this is saying is if I draw my polygon and these are the inside and this is the outside, so it could go like this, it could have more sides to it, I'm just drawing one part of it. If this exterior is 50 degrees, I need to find out what this interior would be. Well, that's just going to be 180 minus 50, so 130 degrees. That's just based on a linear pair principle. Okay, let's move this up, and let's look at this next one. Draw a rhombus ABCD. So let's go ahead and draw this. So I've got my rhombus here. This is A, B, C, D. And if the measure of angle CAD, CAD, so that means I've got to draw this piece in here, CAD, that angle right there, is 40 degrees. And C to E is 5. I should have indicated on here, E is the center where the diagonals cross. So I should indicate that E is this point right here. We should have indicated that in the directions. So C to E is 5. We need to find the measure of angle BCA. BCA, well, parallel, these will be alternate interior. That's 40 degrees as well. The measure of angle CDA. CDA. Well, if this right here is a rhombus, that means it's a parallelogram. So these right in here, that'll be, if this is 40, we said that'll be 40, right? So we've got 40. This will be 40 as well, because on a rhombus, these diagonals will bisect the angles. So this angle in here will be 180. Here's my triangle, 180. Minus 40, minus another 40 gives me this one. So this will be 100. Okay, AC. Well, the diagonals bisect each other, and they're going to be congruent, so AC will be 5. So this piece is 5, sorry. So this AC will be 10. Okay. All right, moving on to the last problem, which is this proof. We're going to have our statements and reasons. And let's see what we've got here. In this proof, we are told that GEO, this triangle up in here, is congruent to OMG, that triangle in there. OMG. So those two triangles are congruent, and I have to prove that it's a parallelogram. Well, there are multiple ways to prove something is a parallelogram. Let's go over those 5 ways real quick. I can show opposite sides parallel. That would be by definition. I could show opposite sides congruent. I can show one pair congruent and parallel. I can show the diagonals bisect each other. Or I could show that opposite angles congruent. Those are 5 ways that I can prove something is a parallelogram. So we've studied that in our notes. I think in this one, since they give us the 2 triangles are congruent, that showing that the opposite sides congruent would be our best option. Because here, let's first indicate that triangle GEO is congruent to triangle OMG. This is our given. And since we have that, I could say that GE is congruent to OM. I can also say that GM is congruent to OE, and this is straight up by CPCTC. Corresponding parts of congruent triangles are congruent. Well, now I know that that's all I need. I just showed that opposite sides are congruent, so GEOM is a parallelogram because opposite sides are congruent. Easy 3-step proof here.